Welcome, everyone. Thanks for joining us for this webinar on RIEGL MLS workflow updates and training tips. My name is Tanner Dutton, and today we'll walk through a handful of updates, practical tips to help you streamline your mobile LiDAR workflows. This will be a mix of a live PowerPoint presentation, as well as some recorded videos giving you live demos and clear insights onto some of our workings with our software. As you can see, our agenda includes going over the process on how to auto extract out targets from your point clouds and automatically tie them down to ground control points. We'll also be reviewing how to use some handy views in RiPROCESS to live QA/QC separation in your point cloud data. We'll also be going over some good tips for running RiPRecision and checking those ground control points. And lastly, we're going to be going over best practices for exporting orthometric pavement imagery. So we'll get things started by looking at the auto target extraction tool in RiPROCESS. So as many of you know, linking ground control points to point clouds can be the most labor-intensive tasks when processing out a point cloud. Using the auto extraction tool with our targets, we can save a lot of time if the work's done upfront to place targets precisely on the pavement, as well as following up, making sure our settings are proper in the software. I've set up a really good example here where 1 foot by 1 foot squares were painted on the asphalt. We used both black and white paint for contrast to get the best results out of the software. And in this example, we're going to take a look at all 26 of 26 targets were auto-extracted by RiPROCESS, leaving no manual work for tying down point clouds to ground control. So the first step in setting up a project for auto target extraction is to go into your RiPROCESS project folder, go to the 06 RIEGL Proc folder, then the 03 Observations folder, and you'll see this Control Object Types JSON file. Double click that folder, and you'll see at the top it gives you some parameters as well as descriptions on how each target type is built in. If you scroll down to the bottom, you'll see some defaults for some targets already in here. For this example, I've already went in and created a default setting for our targets. So you'll see I've named it Checker Horizontal 30 LCFL. And all I've had to do is come in here and change the length, which is the length of each of my squares. This has to be in meters. So you see I've done a conversion from 1 foot to meters. Once that's in there, I simply just need to close this file and then open RiPROCESS. Let's first start by looking at what one of these targets look like in RiPROCESS. So you can see here I've selected a small black and white target right off the right away. You can see this is where the black paint and where the highly reflective white paint was. Next, we're going to go over how to use RiPROCESS to automatically link the exact center of that target and the steps needed to do so. The first step in auto extracting out the center of that target would be to go to Control Objects folder, double click. Let's make that widescreen. Go to your points section, right click, import your control file. So I need to navigate to where my control file is stored. Select your import coordinate system. So you'll see there I've now had all 26 of my targets populate. I now need to just select all of my targets, right click, and hit edit. And now I need to set the target type. And I'm going to locate that LCFL template I made earlier. I'm going to click that and hit OK. And you'll see it's now set all of my targets to that 1 foot by 1 foot checkerboard. Now that that's done, I just need to go to Control Objects, right click, find Tie Objects, select the records I would like to run, select the control points I would like to use, and let the program run through and find the center of all those points. Okay, that has now finished. As you can see, when it finishes, it shows that it's added 88 tie points, and it's finished successfully. So now we just hit close, and we will now see that all 26 control points have been automatically linked to those targets by looking at this link category and seeing yes. Now let's take a look at what those links look like in the point cloud. So we're back at the target that we looked at earlier, and we can see I've already loaded in our control point, and it's sitting on the center of that target. To get the tie points that we have automatically created added to this viewer, we need to go to our View Inspector, go to the Laser Data folder, right-click, and add tie objects to view. The software has now went through and added in all the automatic tie points it created earlier. If I zoom in here, over clipping that 107, you'll see there's a bunch of tie points all sitting on the middle of that target, ready to be used in RiPROCESS to automatically adjust the point clouds. Next, I would like to review and show off some handy tips of using some different views in RiPROCESS to be able to live QA/QC your data of its vertical separation. So in RiPROCESS, we can create these almost high heat maps to show live what the actual data separation is between different drive passes. And this is really handy for understanding what RiPROCESS is doing before it adjusts and after it adjusts to ensure that you don't have any more areas of vertical separation. So you can see here, I have a quick map, and I'm going to show how to create this. This green represents probably about 5 to 6 centimeters of some vertical separation. And after I run RiPROCESS, you can see it's all black, meaning that it's going to be below the threshold I set. Now I'm going to show you how to go through the process of creating these maps yourself and seeing what they look like pre and post RiPROCESS. So as you can see here, I have 2 overlapping passes imported into RiPROCESS using just a regular reflectance view. To populate our height differential, we need to go to View Type, right-click and Edit. Move down to Difference, Laser Data. Change laser data settings to maximum difference between all last data objects. And now change the lower threshold to whatever accuracy you would want to represent. I'm going to have this set to 1 centimeter. Now you'll see this has created the heat map, which shows average point cloud separation between these 2 drive passes. So anywhere we see green here, we're expected to see 5 to 6 centimeters of separation. Let's see what that looks like up close by taking a cross section. We can see there's the separation that the heat map is showing. Now let's run RiPROCESS and see if this map gets any better. Now that RiPROCESS has finished running, you'll see that our map looks a lot different than it did before. A lot of those green and yellow colors we're seeing have now dissipated, and a majority of the points we're seeing on the road surface are black, meaning that it's below our 1 centimeter threshold. So you'll see this area earlier was very green, and now we're either into our blues or black, meaning we're below that 1 centimeter. Taking that same cross section to that same area, we can see that the point cloud now is right on top of each other, showing that this map has correctly represented that the point cloud has now been pulled together with RiPROCESS. This map can be really, really handy for QA/QCing large projects quickly and trying to find trouble areas where you see those greens and the reds, meaning that there's more point cloud separation. Next up, I would like to do a quick review on a quick tip when running RiPROCESS. As many of you may know, if you have a large data set, RiPROCESS can take quite a bit of time to run, and it can be frustrating if you run RiPROCESS and do not receive the results that you wish. There is a really handy feature in the software that allows you to see adjustments that RiPROCESS would like to make without ever running RiPROCESS, so that you can either accept or reject those and go back and resample your control. This is simply done by turning off automatic features when running RiPROCESS and changing the point cloud adjustment to show report only. This process is going to allow you to generate the RiPROCESS report that we all know and love without ever having to actually fully run RiPROCESS. This will allow you to live QA/QC your control points before and after adjustment to see if you're happy with the results and if you would like to continue with running RiPROCESS. Now let me show you how to do this really quickly in our software. So I'm back in the same project that I used earlier for showing off the automatic target extraction, and I'm going to run RiPROCESS on that project. So first, I would go to Tools, RiPROCESS. Don't touch anything the first page. Second page, I want to turn off automatic features. I want to then ensure that all control objects I would like to use are selected. Now, in the summary page, I want to ensure to only have when finished being show report when finished. I'm going to hit OK. And you'll see this task is going to run very, very quickly. And you'll now look, this has produced the RiPROCESS report in only 3 seconds. This, of course, shows all of our good information, showing how much our trajectory is adjusted, the RMS values of those, as well as the important part, which is showing the prior and post separation of our control points to their tie points. So you can see here, these are all the tie points that were automatically created by the tool earlier. And this is giving me an estimate of what the separation from those tie points were to control before and after I ran RiPROCESS. So you can see here, let's just take control point 101, for example. I have anywhere from 2 to 3 to 4 to 1.8 centimeters of separation to my control value before running RiPROCESS. And now after, I'm down to 31222 millimeters on those tie points, meaning that that is a very accurate control point vertically. I can go through this list and look at my values post to ensure that they meet my quality needs. So for example, control point 108 here in post has a few that are showing in the 6 to 7 millimeter range. This could be a good flag for yourself to go back and look at those points and see if we need to be resampled or deleted to create a more accurate point cloud. The really great number is down here in the total mean. This shows the mean separation from our control objects before and after RiPROCESS. So you can see before I was around 3 centimeters and post I'm at 3 millimeters. This is great because I was able to produce these results with almost no manual input. I auto extracted the targets and then I auto ran this report in 3 seconds. And now I can see it. I'm confident to run RiPROCESS and get that accuracy on my control points without ever having to wait for RiPROCESS to run. Lastly, I wanted to go over the new Ortho Pavement tool that is in RiPROCESS. This tool allows you to take camera imagery from the 2 rear-facing pavement cameras for the VMX2HA, the VMQ1HA, and the VMY2 and create full orthomosaics of the pavement surface for analysis. The team has been collecting some data with this tool, and I wanted to take some time to quickly show some of the data off, as well as do a quick run through on how the tool works in RiPROCESS. This is a really good example of the new recent update to the tool. You now can very seamlessly merge multi-pass runs with the tool. This is a great example of a dataset I drove of a racetrack where I have automatically merged 5 different lanes of data into one orthomosaic. So each one of these lanes had images taken every 4.5 feet on the pavement surface. RiPROCESS then looked at the overlap between each pass and was able to create this beautiful orthomosaic of the dataset. You can see this is the full example of the project I created, the full racetrack and drag strip. This picture speaks great volume to the ability of being able to merge these point clouds. Every lane you see here was driven once with these pavement cameras. So even this back gravel road here. So we have 1, 2, 3, 4, 5, 6, 7, 8 different passes that were merged into one beautiful orthomosaic by RiPROCESS. Zooming in even closer, you can start to see the actual crack analysis that can be done with this tool and the orthomosaics it creates. Now let's go into RiPROCESS and look at some fun tips on how you should be running this tool. Now that I'm in RiPROCESS, it's important to note that to run the ortho image tool, you will need to have completed a majority of the MLS standard workflow, as in processing the point cloud, running RiPROCESS, as well as getting a really good calibration on your pavement cameras. Now that I'm to that step, to run the tool, I need to go to Tools, Ortho Image Wizard, select the record that I would like to use. For this example, I'm only going to select one record. Select the cameras, so those will be the two pavement cameras. Set the target coordinate system I would like the imagery to be exported out in. Really, the main setting you need to worry about here is the pixel per meter. This is the actual resolution. This is recommended between either 500 or 1000. And as well as to make sure the time domain matches the time domain you're going to export your point cloud in. In this section, I need to choose where I would like to export the data, how I would like to name that data. RiPROCESS has some really nice scripting options to automatically name those files for you. Then in the Combine tab, I need to choose if I would like to combine all the scan data. This will take into account any adjacent records, and this is what's going to merge multiple records together, or if I would just like to process that record individually. I also have the options to tile the data via a bounding box. Once that's done, I need to add some data filters. It is recommended to put a data filter of left to right. I would say of a negative 1.5 meters and 1.5 meters away from the cameras. This will allow the camera to not sneak too much data of the adjacent lanes while still keeping enough for overlap. Another handy tip, if you want the best data, is that if you've classified all your points in RiPROCESS to ground, you can come here and select point class and choose that point class. For this example, mine class was 18, that's ground. And it will make sure that it only uses the ground LiDAR to produce the orthomosaics. Once that's done, you just hit next and let the task run. I've already ran the tasks. We can see here some images from that record. And it's that simple. That's how you run the orthomosaic tool in RiPROCESS. And lastly, I wanted to thank everyone again for joining us today. I hope these tips help sharpen your workflow and make your mobile LiDAR data processing more efficient in RiPROCESS. My contact information is on the slide above. Please feel free to reach out with any time with questions, or if you'd like to go any deeper in these topics, or have questions on anything else related to RiPROCESS or the MLS workflow. I think now we should open the floor up to some questions. If you have any, please feel free to put them in the chat, and we will answer them right away.